Okay, this is the schematic diagram of our fluorescent display driver. This one has been removed from a very old VCR, which is a video cassette recorder, probably about 30 years old. I've got some pull-up resistors here, and these are all 47k, and they are connected to the anodes. Then further over to the left we've got the grids, and I've only chosen segment B and C, so they're permanently hardwired. Normally you would have decoding of some sort and present the appropriate digit value you want to be in sequential timing with the update of each digit. So we're starting digit 0 through digit 6 here. Actually that should be digit 5, yeah, 0 through digit 5. And driving that we have an open collector driver. It's a ULN 2003. The advantage of that one is we can have probably up to about 30 volts because they're open collector outputs. And the input, very convenient, we can drive it directly with TTL or CMOS. Here I've chosen a CMOS hex inverter. The reason for that being there's built-in inversion in the open collector driver chip, the ULN 2003, so we hence have a hex inverter here to give us inversion. And this one is in turn driven by a walking 1 counter. This one counts 0 through 6, actually counts 0 through 5, so it's only got 6 different states. Once it gets to 6 it automatically is tied back to the master reset and goes back to 0, so it goes 0 through 5 back to 0. Hence the display up here, digits 1 to 6 corresponding to 0 through 5. This one is then driven with its clock signal from another 74C14, which is a simple square wave generator, and we can quite easily vary that frequency between 6 Hz and 500 Hz. Last thing to show, 5 volt power supply, 25 volts in, 5 volts out, and we have common ground, also filament common ground over here, and on the far right a separate 3 volt supply only for the filament. So we need 25 volts and 3 volts. 5 volts is generated internally by a 3 terminal regulator. Okay, so we have our clock generator over here. That goes into a walking 1 counter, and that will give us digit 0 through to digit 5. So hence 6 different digits. We never get to digit 6 because this walking 1 counter is auto reset. It's got a feedback from the Q6 output back to the reset. Now the next chip along to the left here is a hex inverter. The reason we need to have that is the one that drives the display directly is an open collector driver, and its inherent nature, it's got inversion internally, so we need to have this inverter preceding it. Now if we look up here we can see it's around about 5 Hz, so I've got it on the lowest setting. Now you watch the trick displayed on the eyes. If we can scan this a lot faster, in other words refresh the display, I'll turn this control up, increase the clock speed, so you're getting faster now, and if we update it, the magic figure is probably about 50 times a second, we should be able to stop that flicker. It'll look like it's a permanently stationary digit eventually. And very close, very close. We're just about there. Okay, I can't really see any flicker there now. If I got around about 500 Hz, yeah. So you'd have to divide that by 6 to get the true reflection of how often it's refreshed, because we're actually doing 6 digits sequentially, starting digit 0 through digit 5.
Thank you for watching.